Hello, today's topic is the optimum spraying height. For many decades, we have been running with a spraying height of 50 centimeters and nozzles 50 centimeters apart. In recent years, a spraying height of 25 centimeters is also recommended with nozzles 25 centimeters apart. In theory, the lower the nozzles are, the less overlap. There is a risk of worse lateral non-uniformity with a small overlap. The nozzle manufacturer tells us that when the nozzles are 50 centimeters apart, the spraying height should be 40 to 60 centimeters. If the nozzles are 25 centimeters apart, the spraying height should be 30 to 50 centimeters. If you take the minimum of 40 centimeters, you can see that the nozzles overlap by 1. That is, if they are 50 centimeters apart, the minimum is 40 centimeters above the ground and overlapping by 1 nozzle. If we add the Earth's apparent weight and air resistance, it should be a few more centimeters. The same applies if the nozzles are only 25 centimeters apart. It won't be just 30, but a few extra centimeters. We don't have completely flat terrain. We don't work at an airport. There are some deflections. Also, our boom springs up and down, so we have some extra centimeters of clearance to make sure we don't get right under the nozzle over a bump. Here you can see when we used a 25 centimeter spraying height. You can see the turbulence because the air just above the ground has resistance and carries the droplets away. At 40 centimeters, it's less. Then if we look at 50 centimeters, it's even less. We can say that at 70 centimeters, we have no turbulence at all. But again, at 70 centimeters, there is a risk that the droplets will be carried away by the wind. So 50 centimeters is some kind of optimum. If we work with PWM, i.e. with pulse modulation spraying, where it sprays periodically at a speed of 15 kilometers per hour and a frequency of 20 Hz, we alternate 10 centimeter strips when spraying with 10 centimeter strips when not spraying. If the nozzle is too low, there is too little overlap. Here you can see the side view of the nozzle. At 25 centimeters, it is 8 to 9 centimeters, and at 50 centimeters, it is doubled. We decided to measure how the liquid is distributed in the longitudinal direction. Here you can see the 2 centimeter wide grooves. There are 10 in total, so that simulates 10 centimeters when spraying and 10 centimeters when not spraying. At a spraying height of 50 centimeters, the distribution was such that we measured 750 milliliters directly below the nozzle and only 80 milliliters at the edge gutter. Looking at a spray height of 25 centimeters directly under the nozzle was 1000 milliliters, and at the edge gutter it was only 80 milliliters. This means a significantly larger difference between the place under the nozzle and at the end. It can be said that with a PWM system which alternates between spray and non-spray locations, the nozzles need to be quite high to avoid a lot of unevenness in the longitudinal direction. We also have to remember that in PWM, we add longitudinal non-uniformity to the normal unevenness in the lateral plane. So we may encounter places in the field where those extreme deviations merge and we get even more irregularity. If I take the classic example of spraying at a spraying height of 50 centimeters, nozzles 50 centimeters apart, giving 200 liters per hectare, a speed of 12 kilometers, it works out that I have to spray with a red nozzle of size 0.4. If I want to spray with a spraying height of 30 centimeters, it must have twice the number of nozzles but half the size. So instead of 0.4, I need to spray with 0.2. The 0.2s are already so small that they clog up, and in practice, you have to put strainers in front of them. These strainers have the disadvantage that they are both hard to mount and remove, and they clog unevenly because the dirt in the hoses and tubes flows to the end usually. So the end strainers are more clogged than the strainers at the beginning. In practice, the tractor operator may not even notice this, and the edge nozzles will only spray 50 litres per hectare, and the ones at the start will spray 400 litres per hectare. Generally, it will work, but it will be done terribly badly in the field. The sieves are always a risk to the quality of the work. The optimum spraying height is a compromise of various parameters, and the result of this compromise must be optimum work quality. It is about treating on time, about treating every square centimetre with the same rate so that everywhere on the plant, from the front, from the back, on the clumps, from the front, from the back, we have the same rate, so that we do not have places in the field where there are shadows, where the active substance has not reached the field at all. A standard spray height of 50 centimetres, a nozzle spacing of 50 centimetres, and a double flat fan nozzle that treats everything from two sides. I think that's the best way we can do plant protection.